All right, everyone, let's get started. The sooner we start, the sooner we can go to the bar and get some more beer, right? So, yeah, there you go. At least one person agrees with that. So this is a session on JavaScript design patterns. And just to give you a little bit of background, I'm like most people in this room in that I started off and worked in the enterprise Java space for a very long time, up until a few years ago when I started a startup company with some friends. And going from enterprise Java to doing JavaScript full-time basically was very eye-opening. Is the best way to put it. So what I've done is I've collected some of the experiences in going from being an enterprise Java developer to being a full-stack JavaScript developer, and I've distilled them into this talk and a couple of others that I've given today. So we're going to discuss JavaScript design patterns, and we're going to spend some time going through code examples. So if you have had beer, you may need to wake up a little bit because we're going to go very quickly through the code examples, and some of them are complex, okay? Also, our goal is to understand the patterns. It's not so much to learn them and start using them as soon as we get to work, tomorrow or whenever. Again, our real goal is to understand how these patterns manifest in JavaScript, how we use them, how frameworks use them to build their features, so that if you're using something like Angular or Backbone or Ember.js or Batman or whatever, you have an idea of what's going on underneath the hood. Because oftentimes there's a lot of magic that happens in JavaScript, and we'll see some of that magic today when we work through the code examples. So it's useful to understand exactly how this stuff is put together, right? You may not necessarily need to implement a command pattern like we do in an example later, but it's useful to know that the command pattern is used by pretty much every framework to inject its functionality into your code. All right, so speaking of frameworks, there are a ton of frameworks out there, right? If you guys have been following the JavaScript space at all, you know that there are tons and tons of these frameworks. And it's kind of difficult to choose one. It's like, which one should I use for my project? So hopefully, the other thing that you'll get out of this session is as we go through and we talk about these patterns and see how they're implemented in something like Backbone or Angular, you get a better idea of how these frameworks pull these patterns together to provide their functionality. So, typical question is, why even bother using a framework? Well, there are two basic reasons, and you probably know these two. Number one, JavaScript provides little in the way of a utility or abstraction. In the Java world, we have static typing, and we have this recipe that we follow for building applications at the code level. But in JavaScript, we don't have that. And the first pattern we'll talk about, the namespace, we'll see that even the basic constructs are sometimes missing in JavaScript. And what happens is even small projects can become a mess very quickly if we're not careful. Right, so, the other thing is when you don't have a nice structure to build your application out from the beginning, you end up writing a lot of boilerplate and you end up doing a lot of copying and pasting, which obviously is bad, right? Reusability becomes an issue. So even before you dive into these frameworks, some of the things that we like to use and other people in the JavaScript community like to use are the things that are listed on here. There's underscore and sugar.js. Those are low-level utilities for working with collections and other things like that. And then for working with dates, you also have date.js and moment.js that make working with dates much, much easier than just trying to do it yourself. So these are some of the things that we use on pretty much every project, whether it's on a mobile phone, on the server, or on the web. All right, so again, I'll issue this warning one last time. The idea is not to learn these patterns and start coding them up in your JavaScript code base. The idea is to come in, understand how these work, how they're used in frameworks to build their functionality, so you have a deeper understanding that when you use Angular or when you use Backbone or whatever it may be, exactly what's going on underneath the hood. All right, so let's talk about JavaScript patterns. So there are a bunch of creational patterns: the constructor, factory, abstract, prototype, singleton, and builder. You probably recognize some of these. Most of you have probably used several of these, right? Especially the singleton or the factory or whatever. In terms of structural patterns, we have these in JavaScript as well: Decorator, Facade, Flyweight, Adapter, and Proxy. So we're not going to talk about all of these. What I've done is I'll pick some of the ones that are more interesting, and we're actually going to either look at them in code or actually implement them. All right. In terms of behavioral pattern, again, you probably will recognize these. These are things like the iterator, mediator, observer and visitor patterns. But let's start off really basic. There's an organizational pattern in JavaScript that's missing, and that's the namespace pattern. Okay? How do you do namespacing in Java? It's not a trick question. Trick questions come later. How do you do namespaces in Java? You use a package keyword. Exactly. How do you do namespacing in a JavaScript? Using objects. Okay. So that is absolutely correct. We use objects, and obviously we need to have namespacing to build large code bases and to get reusability. So what we do in JavaScript to build objects which are namespaceable is we essentially start with a global empty object. Like if you look at the code here at the top, let me make sure you can see that. Yeah. If you look at app, for example, what we're doing is on this line we're saying app equals app if it exists. If it doesn't, create an empty blank object. So now we have a global variable called app that's referenceable anywhere we need to see it. And then we can build on this and we can say app.services equals app.services if it exists, else initialize it as an empty object. So, and you can start affixing things directly into that namespace like so. So you do app.utility, and this is what's known as a immediately invoked function call. And we'll talk about that in a few minutes, why we specifically have written it in this style. But once you have these namespaces, you can come in and do app.services.userService, for example. Okay, and you kind of get the idea just by looking at these simple code examples exactly how we build up a code base in JavaScript. Right. So again, namespaces are super simple, but unfortunately, JavaScript is missing what I consider to be a mid-level construct in the language for doing something as basic as packaging. Right. So again, we're using a JavaScript object literal to create our namespace. And one thing you have to be careful about is that this is a single global object. So it's a global object. So that means as you create this namespace and you add stuff to it, what's the one thing you have to worry about? You have to worry about how much memory you're using, because this is in the global namespace and it will never get garbage collected. So anything you create in this app namespace, right? So we created app, and then we created services, and now we've created a user service. All the stuff that we have in here will get scoped into the global namespace or the global scope, and it won't get garbage collected. So you have to be careful that you don't stuff too much stuff into here. For example, if we had another service in here, let's say it was a calendar service, and it went and fetched all the calendar entries for this year. Right? If you're not careful to release those objects manually, you will always retain those things inside of a calendar service, for example. So you have to be careful, and you have to understand that this is a single global object that's bound into the JavaScript context and does not get garbage collected. So you have memory issues that you may need to worry about if you're not careful. All right, so let's move on to the first major pattern, and this again is an organizational pattern called the module pattern. Right, there are a few variations of a module pattern. The most basic one, one I've already showed here, is basic plain module pattern. What we do is we say app.utility equals this thing right here. Now, what we have here, and I'm sure there's some people in here that know why we do this. What's the only way in JavaScript to create a scope? By creating a function. So if there's no such thing as block scope in JavaScript or class scope or whatever. The only way to create a scope in JavaScript is by creating a function. So that's what we have to do. And it's so common, in fact, that this stanza right here, along with this is essentially a anonymous function that we're creating. And here at the end, you can see we have an open close parentheses, which means go invoke that function. So we create an anonymous inline function and we invoke it immediately. Right? And this is so common, it has an acronym in IIFC, sometimes known as an IIFE, immediately invoked function call or function execution. And the only reason we do this is so that within this function scope, we get scope safety. So we can create variables in here that won't conflict with any variables that we have in an enclosing scope. Right? And the other thing we've done here is we've done a return statement, and in this specific case, we're just creating an object literal and exposing it. You can see I haven't actually implemented anything, but the way we would call this then is we can come down here and we would do app utility is not string and isn't string. And when I run this, you can see here on the bottom that I'm just printing it out. I haven't actually implemented it, but you get the idea, right? So this is a basic module pattern. So we want to build on this and do something a little bit more elaborate. and that is what's known as the revealing module pattern. All right. So this is slightly different than what we've done before. So here we have our user service, and I think I've got the whole thing on the screen. Obviously, I've stubbed out the actual implementation here. But again, we have app.services.userService equals this thing. And then here's our immediately invoked function call, again, to get scope safety. And we have a few things in here that we're exposing to the outside world. So you can see from the code highlighting exactly what we're exposing. So the first thing is, when we go to the return statement, we're creating a new object literal that specifically gets returned and assigned into this user service variable, right? And within this object literal, we have specific keys: login, logout, get username, uname, etc. And what we're doing is we're mapping those keys to things inside of the object. So you can see we're mapping login to login, and then for demonstration purposes, I've called the logout internal. So we're essentially specifically saying that I'm going to create a new object, and this is exactly what I wish to expose to the outside, i.e. what gets assigned into this user service. Okay, and to use this, what we would do is we come in here, and I have some code right here already. Just uncomment that. So again, I have app services user service. Here's my login. You can see from the code highlighting exactly how that traces back. And I'm going to log myself in with the super secure password and my username. And then I'm going to print out the usernames. Let's go run that really quickly. And you can see here at the bottom that indeed we logged ourselves in with logging in user. And then we were able to get the username out of it by calling get username. So another thing I have here is this username variable. Okay, and I'm directly, instead of exposing a function here, I'm exposing this uname directly as the variable that I assign here. And you can see here's the username from the syntax highlighting. We just called login and we called logout internal. All right, what's going to happen when I run this line right here? If I just do appservices.userservice.uname, will I get my name out, Pratik, or what should I get out? What do you think? Okay. And so a bunch of folks have answered it properly. We get empty out. And the reason why we get empty out, let me just go run this and prove it, right? You can see we get empty here. The reason for this is, again, this is JavaScript, which is an interpreted language. So as we're parsing this file and executing it from the top, we start here, and then we come down to the end over here. And at this point in time, when we hit this return statement, again, this is an immediately invoked function call, not a function call we evoke later in time. We invoke it immediately in line in this application. At this point in time, when we hit this return statement, this username is actually set to empty. Okay, so this is a little bit of a caveat. You cannot directly expose a property like this in a module pattern. You can, but you have to be careful that when you set it, and you think that, oh yeah, I'm just going to expose the username by aliasing it like this. It actually doesn't work like that. Because it's an immediately invoked function call, we start from top to bottom, and at this point in time, the value of this username is still empty. All right? So there's another thing that some people do in their code is they go in and they add stuff on the fly. You have to remember that JavaScript is an open language. You can change anything at any given point in time whenever you want. Right? It's both very powerful and obviously very dangerous. So you'll see some people actually go in and modify existing objects like this. So if we go run this, you'll see we got the city right here. We basically added a new function into that user service object literal that we returned here. Right? But this is not something that we commonly do. We like to define everything inside of the object itself, and if we need to expose something, we actually go and write the function directly inline, and obviously I need a little bit more here. So if we get city, we would expose it directly like this. So we don't typically tack stuff on at the end or after the fact, because it just makes the code base a little bit less readable. Right? Now, one of the things with this is, with this specific module pattern, if I haven't written this user service, or say we have an event service or calendar service or whatever, one of the things I can do is I can come into this file and say, okay, here's the user service. I need to log in the user and do some other stuff with the user. I can come to the return statement and say, this is the API that I'm exposing, or the developer that wrote this is exposing. So it's a nice way of coming in and saying, okay, So this user service has 5 different functions inside of it, log in, log out, and you kind of at a glance you can see exactly what is exposed. So this is a way of exposing a course level API into underlying services, right? And this is why this is popular in JavaScript, because you're able to go in and you're able to essentially build something at a course level rather than at a fine level. When I say fine level, I mean something like a class file, right? We're not creating a class here, or what would be considered the equivalent of a class. We're working at a slightly higher level of abstraction, i.e. at a module level, where we have a coarser level API into a group of related services or related functions. All right, let me back this out, make sure everything works. All right, so the other thing that is uncommon to do, but you might see some people do it, is you can actually go in and you can directly set, right, before we set a new function directly into the user service like this. You can also do the same thing by going in and directly setting a property if you want. Again, we try not to do this. We try to use getters and setters. And I know getters and setters may be out of fashion now, but when we're talking about the module pattern, we want to make sure we define it in such a way that we still have the scope safety and everything makes sense, and we don't do magic afterwards, right? Doing magic afterwards is always dangerous. So we try to avoid doing that as much as possible. All right. Let's move on to the next example. So that was the revealing module pattern. The next variation of this is what's known as the import mixin module. All right, so if we go have a quick look at that, let's see what it looks like. All right, so we have another service I've defined here called event service, and I've aliased this into, again, our global namespace pattern using app.services.eventService. I've just aliased it, right? So there are a couple of ways that we could actually use this event service inside of our user service if we wanted to. What I can do is I can come down here and I can directly reference app.services.eventService.addEvent. So if I just comment this line out for now, okay, and go and execute my login where I'm calling this other event service, and this event is JS patterns, so you can see that works. Another style that some people use, and especially if you're looking at Angular, they kind of use this style as well. What you can do is, because this is just like any other function call, I can take this EV service parameter that I've bound into the function, and right here you can see I have ES. ES is the original declaration of my event service. So what I'm doing is I'm passing this ES into the inline immediately invoked function call, which gets bound into EV service, which will then get run here. Okay, so instead of JS patterns now, we should get Keynote out. So if we run that, you'll see that indeed works. Okay, but this is what's known as an import mixin module. Now, does this remind you anything from the Java world? Right, so the answer is dependency injection. Okay, so you can do a lot of the same things we do in the Java world in terms of dependency injection, mapping different types of objects together, building coarser level APIs. You can do all that in JavaScript, but the style is slightly different. So this is an example of doing DI within JavaScript. All right, so we've covered the modules. Let's move on and talk about the pub/sub pattern. So the publish-subscribe pattern in JavaScript is very similar to the classic publish-subscribe that you're probably used to in the Java world. Okay, what it's used for specifically in the JavaScript world, though, is used for doing things like dynamic updating of UI elements, doing data synchronization, other things like that. The idea is that you have a publish-subscribe mechanism set up which allows you to send a message onto a channel, and then somewhere else in your code you can listen for that message and do the appropriate thing. All right? So in terms of how this actually looks, if we go look at an example from Backbone, the collection that we have here, to-dos is a collection of model objects in Backbone. When we hit the dot trigger in this specific Backbone collection, that is actually using a pub/sub pattern underneath the hood. So it's broadcasting an event to everybody that says, go do a reset, and here's some extra data along with it. And then on the other side, you can listen for that reset event by doing a to-dos.on and listen for the reset event, and you get the data that was originally passed in. Okay? So again, it's very simple in terms of how it's structured, but it's useful to know that we are using a publish-subscribe mechanism here. And in fact, you don't even need to use something like Backbone to use pub/sub or any framework. It's actually built right into jQuery. So you don't see this style a lot, but for example, on the second line there, we have element.trigger on login, here's some information, right? And then we can listen to it on the other side with element.on login, and here's the stuff that we're getting back, right? So this is actually baked right into jQuery, and you'll see some advanced jQuery users use this to bind elements and basically create a channel around a specific element. In this case, the channel that we're creating is around the EL that we have a reference to here. Okay, so you can actually create a channel down to the element level within jQuery itself, right? So one quick thing I do want to mention is normally when we think of PubSub in the Java world, we usually think of JMS, right? JMS is, Java Message Service. And when we think of JMS, we think of it as something that's distributed across, possibly distributed across servers, distributed across processes, etc. When we talk about publish subscribe in JavaScript though, publish subscribe in JavaScript is all in process. That means that if you have a web browser tab open with the app and you have another web browser tab open with the same application, those two tabs aren't going to be able to talk to each other. Publish subscribe in JavaScript is all within that one JavaScript context. It is not distributed between threads or processes or servers or anything like that. Okay? That's a key difference between how we think of PubSub in the Java world as compared to how we think about it in the JavaScript world. PubSub is all within process, all within that one JavaScript context or web page running. All right. So quickly want to mention the observer, because the observer pattern is something that folks have used before. It's similar to PubSub, but typically when we talk about the observer pattern, the observer has to subscribe to the subject. So what we have is we have tight coupling between the observer and subject. And in fact, when we talk about the PubSub pattern, it actually uses a third design pattern called the mediator that allows us to have loose coupling. So we typically don't see implementations of an observer pattern in JavaScript because we want to have loose coupling. And the main reason why we want to have loose coupling and fire events into channels in JavaScript is because of JavaScript's single-threaded and asynchronous nature. So we have to be careful that we don't lock up the main thread of execution in JavaScript. Hence, we want to have that decoupling. We'll be able to fire an event, and then way over here, someone can listen to that event, pick it up, and work with it. All right. So the next pattern we want to talk about is what's known as the command pattern. A command pattern is like a classic command pattern you may implement in any other language, Java or Python, Ruby, whatever it may be. Essentially what it does is it allows you to do delegation of function/method invocation, right? The reason why you want to do that delegation is for two main purposes, so that you can do indirection and invocation chaining. Right? So let's actually start from the beginning and code up a quick example of this specific pattern. All right, so we have a couple of things here. We have a car manager here, which is just an object literal, and it has a couple of things in here. Request info, buy vehicle, arrange viewing, audit sale, whatever. Okay, you can see I've just stubbed those out for now. So the way that we would typically invoke something in an object is by using standard dot notation. So let's say we wanted to buy a Honda Prius. We would do car manager.buy vehicle. Right, so if we run this, actually let me go comment out this extra stuff down here so that we don't get noise. All right, so you can see we have car manager.buy vehicle, and we bought a Prius with this number. Right? Another way that you can do a function invocation in JavaScript is by going and grabbing the specific underlying property. In this case, it's a function, by using the square brackets. It's almost like using an array operator, right? So we say car manager, square bracket, the string of the name of the property that we wish to get, and then you can see I have an open close parentheses, and we're going from buying a Honda Prius now to a Chevy Volt. You can see that works. Right. Yet another way to execute a function in JavaScript that's contained within an object is by using the apply keyword. So what we do again here is we say go and get that buy vehicle function that's contained within this car manager. Right. So that's what the square brackets and the string does. Dot apply is a keyword in JavaScript that allows you to execute something by setting the context in which it gets executed, the this variable that is present inside of an object, and then followed by an array of the actual parameters. So now what we're going to do is we're going to buy vehicle, use apply. This is the context in which we're going to execute that specific function, and here are the parameters we're going to use. Okay? So if we go run this, you'll see now we've moved up from buying a Chevy Volt to a Nissan Leaf. All right? So a couple of different ways so far we've seen of being able to go and execute something. And now we're ready to start building our command pattern. All right, so a few things quickly in that when we want to implement a command pattern, we'll give it something like this. We'll say, let's add a new function to car manager called execute. Here's the function definition. What we'll do is we'll specifically ask it for the name of the underlying function within the car manager that we want to execute. In this case, here's the name variable. You can see from the code highlighting where it appears in here. And then we do, as we saw just a second ago, car manager, name of that function, the apply call to invoke it, the context in which to run it. And here I'm using _rest operator to say, give me all the arguments except for the first one. What rest does is basically takes off the first argument and returns you the rest of it. In this case, I've set it to 1. So it'll take off this name, and any other stuff that's passed to it will get pushed into the specific REST call. Okay, so if you don't remember your JavaScript, let me go run this really quickly. Let me show you what the arguments object looks like when you execute it. So I'm going to call car manager, execute, buy vehicle, and now we're getting somewhere. We're moving up from a Nissan Leaf to a Tesla, right? So let's go run this really quickly, and you can see that this is what the arguments object looks like. It's essentially the way JavaScript implements variadics, right? You get this object called arguments, and it contains all the arguments that were passed to it, and you can see that the first parameter there was buy vehicle, and then the other parameters are here, Tesla, 1, 2, 3, whatever, okay? So now we've introduced this indirection. We can go do a couple of interesting things, right? So we have this execute function. So we have this function here called debug logger. Let's say as part of my command pattern, I just want to print out every time which function was called. Okay, so it's like a debug logger or some kind of log that we want to introduce. So I'll put in my debug logger and we'll print out the name that actually gets printed out, the name of the function we're actually invoking. All right, and let's get rid of, we don't want this arguments anymore. So first we'll debug log the name of the function, then we'll actually go execute that function, return it, and then down here print it out. All right, so let's go run that, and you can see that our debug logger has been invoked. You've called this function, right, by vehicle, and then the actual function itself, you've successfully purchased a Tesla, right? So we've added some debugging to this. Let's actually go in and change the results in some way. Let's say we wanted to take the results that we had and we want to annotate them in some way. In this case, I'm just using a simple string. So we'll say when we run annotate results with the string, it'll just prepend this string to the actual results. So let's go put that in here, okay? And let's go run it again. And now you'll see that we have our debug logger here, and we've also changed the results in some way. In this case, we're just working with the string, so we've just prepended something to that string to give us some extra stuff, right? So after watching me work through this example, what does this remind you of from the Java world? What was that? Right, this is a lot like doing AOP. We have some around advice that we attached to modify the result, right? We put a little before advice to print out some, lock statements, whatever. Right, so this is obviously in JavaScript we don't have annotations. It's not. There's no way in the language itself to go and actually manipulate the abstract syntax tree once the JavaScript compiler has compiled it and is getting ready to execute it. Right? We do that in the Java world by using a combination of aspects and doing bytecode injection directly into the class files. But you can't do that in JavaScript. So what we have to do to build up these frameworks and these more sophisticated solutions is we do things like this. Okay? We introduce this indirection by using a simple command pattern that gives us the power to put around advice and do other things like we're used to doing in the Java world. Right? So there are a few other things we can do here. And if we go look, so far we've just been calling by vehicle, right? But we can also go request info, and if I go run this, you'll see that this works as we expected. In that, well, it helps if you print out the result. You can see that this works as we expected from the request info. So it works for basically any function that we have defined within our original class. We've introduced some indirection, and it gives us the freedom to be able to do extra stuff around it if we want. All right? So if we get back to our slides, we'll talk a little bit more about how the command function or command pattern is actually used in JavaScript. But if we skip ahead a little bit, I'll point out specifically where we see some of this stuff. So if we go into a model object, is this the right one? All right. So if we look at a model object in Backbone, for example, this is how you create a new model object in Backbone. You say var item equals new item. I've done some preliminary work before this, but when you actually want to set something against the model, you don't just do item.name equals pencil or item.color equals yellow. What you actually have to do with almost all these frameworks, doesn't matter if you're using Backbone or Ember.js or whatever, for a model object, you have to do item.set or model object.set, and you have to pass it in a dictionary of properties that you wish to set against that object. Okay? And the reason why they specifically make you do it like this is because of what we just discussed. How is the framework going to be able to broadcast a trigger event if you just go directly set a property on an object? It's not possible for the framework to do that. So the set in this case is our command. The dot set is our their implementation of a command pattern. And what they do is they take that data in, and then they set it on some internal data structure that they use to map the properties that are in this model object. But they'll also broadcast a trigger. They'll also trigger a change event so that somebody else on the other side can say, oh, someone just changed the model. I'm going to go do something with that data. Go update the UI or go flush that change back down to the server. Okay? All right, so let's get back to where we were in our slides. Not that far back. All right. So the next thing I want to talk about very quickly is we also have a facade pattern in JavaScript. And you guys will recognize a facade as being something that usually abstracts away something that's more complex underneath, right? So we actually did something like this already. If you remember the user service, in the return statement, we said we just want to expose these things out of our user service object. So we essentially presented a facade to the outside world and said, this is all we're exposing, and the underlying implementation may be more complex or whatever, right? So we've already done a facade, and they're pretty easy to do in JavaScript. All right, so the next pattern is the classic factory pattern. And the factory pattern, if you don't remember what it is, it's used for creating objects in a very specific way, right? Rather than just go newing up a new item or whatever, you use a factory and it generates an object for you in a way that you specifically defined it, defined by the developer. Most frameworks actually use the factory pattern in one way or the other, right? What does this look like? I'm not going to implement one right now, but if we go look at Backbone again, for example, when we do a backbone.model.extend, we pass it in some initialization parameters. What that is actually doing is that's going and initializing a new model object with all of the Backbone stuff inside of it. So when we go hit that extended, we're hitting a factory pattern in Backbone that goes and initializes an object, a Backbone model object in a very specific way with all the functionality inside of it, and returns us a new instance of that object, right? So we'll see this a lot when we work. If you're working with virtually any framework, you'll see various uses of the factory because the framework has to have some way of giving you objects back that implement that framework's specific functionality. Right? In this case, we're talking about a Backbone model. All right. So the next one I want to talk about, and this is particularly useful for a number of different use cases, is the Mixin pattern. This is essentially a way of inheriting properties from a base object. It's like an augmentation or extension type of behavior. Right? So if we go look at an example of a Mixin, let's go to our next example here. So I have this my Mixins here. We have a move up, move down, and a stop here. Okay? And then we have our base object, which is a car animator. Car animator can only move left and stop. Not a very useful car, right? So let's go in. Let me actually comment this stuff out for now. We'll come back and work with that some more in a minute. All right, so let's go and new up our car animator, and let's make it move left. Right, that's going to work. If we take this stop out of here and go run this, right, you'll see we'll get an error because we don't have a stop in this car animator, right? But we have a stop function in this myMixins object. So what we want to do is we want to take this myMixins, which implements move up, move down, and stop, and we want to mix it in, or essentially merge it into a base object, in this case, car animator. So what we can do with that is, we can use underscores extend function and say into the car animator prototype, mix in myMixins. Okay, so now when I run this, this is still going to break because I still have the myAnimator.stop up here before applying the mixin. Again, the mixin is up here, and this is the stop function that we're trying to get to. Okay, if I move this down a little bit, if I come down here and take this out and then mix in myMixins into the car animator, you'll see now that we run this, you can see we get that stop function actually appearing inside of our car animator, right? So there are a few other things we can do with this. You don't have to, you're not limited to just mixing in one thing into a base object. You can actually mix in multiples. So I have this other mixin here called other mixin, and inside of that we actually have a fly function, right? So now we're getting somewhere. We've gone from electric cars to flying cars, right? That's what I want. So we have a fly function. We also have stop and move up and move left, but let's see if we can mix in two different things here. So we have extend, myAnimator, other mixin, and myMixins. So let's see what happens now. Let's see if we can get our fly that we have in, the only place this fly exists is in other mixin. You can see it's not in myMixins or in the car animator. So if we go run this, you can see it actually worked and we printed out I'm flying, right? So that begs the question though. In my myMixins, I have a stop. In my other mixin, I also have a stop. If I mix both of these things into my car animator, which one should run, right? We have, so you can see I've labeled this myMixins.stop or myMixinStop, and we have other mixin stopping. If I come down here and mix in both of these into the car animator, which stop should I get out of this? What do you think? Should we get the one from other mixin or myMixin? All right. So you can see that when we hit this, let me clean this up a little bit. Right, so when we hit this, you can see we indeed got it. We got the one from myMixin. So the way that underscores extend function works is that it mixes in from left to right, and it will clobber an existing property that is already there as you go from left to right, and you mix in and basically weave a new object in to a base object. Right? So you have to be aware that if you have the same property or the same function somewhere, you will clobber something that exists if you're not careful. All right. So a lot of people ask, well, this is a little bit of a contrived example. How does this actually work in the real world? So what we actually do in our code base is we have something called base properties, and those base properties will set the background color and the text color and the font size and other things like that that we want to have when we construct widgets within our application. And we'll have base properties, and then a label property will have a font size, or we may have some more specialized properties for different types of widgets, buttons and this and that. But we'll always want to use our base properties of background color, text color, etc. So what we actually do is we'll actually mix in base properties into more specific properties and create essentially this shallow hierarchy of different properties that we want to apply to widgets, again in JavaScript within our application. So this is very specifically how we use it. Obviously there are other uses as well for using mixins, because mixins are essentially a way of just doing object augmentation. So there are a couple of different things we can do. One of them, as we saw here, is we extended a base object called car animator. In this case, we just extended object literals to do something specifically around properties and not functions. All right. So we've covered these two Mixin examples already. And what I want to do is I want to spend a couple of minutes talking about the prototype pattern, right? We actually try not to use prototypical inheritance within our code base, but I feel that it's important to understand this because lots of people use prototypical inheritance, especially when you look at examples for different types of usages of frameworks out there. And what we do in a prototype inheritance type of pattern, right? This specifically is what's known as parasitic inheritance. We have a base object here called vehicle prototype, and we want that to be essentially the superclass, for lack of a better way of saying it, of a vehicle, right? So you can think of vehicle as being the superclass, and this is our base class or subclass of the vehicle prototype. What we do in JavaScript is we create a new blank function. We set the prototype, i.e. we set the superclass manually to be the vehicle prototype that we saw above it. We new one of these things up so we get an instance of that thing. We may do some initialization, and then we return that F. So if I go run this, you see that indeed it works. But we try to avoid doing prototypical inheritance as much as possible because we find that using mixins and using functional JavaScript techniques actually works better than prototypes. And this is our opinion of it, at least. We find that doing prototypical inheritance in JavaScript is very verbose and is something that is quite brittle. So it's difficult to manage this code over time. It's easier just to use a mixin and mix in properties at a base class into a base class than worrying about doing inheritance using prototypical inheritance in JavaScript. All right. So everyone is probably familiar with the decorator pattern. This is similar to a mixin when we look at it at a fundamental level. And it's yet another alternative to subclassing. It allows you to change or extend the behavior in an existing class or object. In the JavaScript world, it is possible to use a decorator, but we typically don't use a decorator. We'll just use something like a facade or even a mixin to provide the same kind of functionality that we would do in a decorator. So we're not really going to talk about this in detail because it's not something that's commonly used. Okay? So the last kind of set of patterns I want to talk about is what are known as the MV star patterns, right? This is something like MVVM, MVP, and obviously everyone is familiar with MVC. Now, I don't want to go into super detail on all these three different patterns, but what I want to point out is that when we first started doing client-side JavaScript, we were thinking of this diagram, right? Everyone has seen this diagram. They probably have it seared into their brain from years of working with struts or with Spring Web or Grails or whatever it may be, right? Play framework. All these frameworks implement the MVC pattern. The thing is though, when we think of this diagram, when we think of MVC, we're thinking about server-side MVC. It is totally different than MVC on the client, okay? So, and for those of you who are already working with Angular or Ember or Backbone, you probably have already come to this realization. But for those of you who are just getting started in it or are getting to the point where you want to start using a framework or anything to build a single page application, this is not what we do, right? What we typically do is something like MVVM, okay? MVVM, and again, I'm not going to go into this in detail, but you can see the diagram is different. There are a couple of things I do want to point out quickly, though. This is JavaScript. This is a client-side pattern for doing model view controller, basically, okay? But we don't have a strong concept of a controller when we talk about doing client-side MVC. And the other thing is that we're heavily based, instead of direct method invocation, so if we go back to the MVC, if you look at some of the lines that are here, a lot of these lines are essentially direct method invocations between the different layers that we have, okay? But when we talk about MVC or MV star in the JavaScript world, a lot of the stuff happens asynchronously or via pub sub channel. So you can see there's a line in the middle that says it sends a notification from the view model up to the view to go tell it to update itself, okay? That notification, as you can guess, is usually a publish subscribe pattern or publish subscribe mechanism somewhere that says, we just changed something in the data. if anyone's interested, here's a notification. Go update yourself, right? And again, the reason why we have to do that is because JavaScript is single-threaded and it's asynchronous in nature. So we want the program in an asynchronous way, and asynchronicity is facilitated by using a publish-subscribe type of pattern, right? So I've already talked about a couple of these different things. When we talk about MVP, actually, right, MVP is what Angular actually implements. So if you're using Angular, this is the kind of the model that it uses. Now, how many folks have done Windows Form programming from the 90s? Anyone that old here or that crazy? Okay, yeah, a few people, right? So if you've done like Windows Form, or if you've worked with some of the other kind of client-server technologies from the mid to late 90s, if you go actually look at Microsoft's documentation, you will find this pattern there. So this pattern is not something that has been invented recently. It's actually been around for a long time. And again, if you go look at Windows Form programming, they specifically talk about implementing the MVP pattern, and the diagram looks basically exactly like this. Okay, so these patterns have been around for a while, but now we're applying them because we're building single-page web applications. We're applying them into the browser, and everyone's like, "Oh my God, look at these crazy new patterns." Well, actually, they've been around for a while. We've just repurposed them for a different age now, right? Running in the browser and running in JavaScript, rather than doing traditional client-server with Visual Basic or Forms or Delphi or Power Builder or whatever you want to, whatever tools we had from back in those days. All right, so I've already talked a little bit about MVP. So a couple of things I want to leave you with. The stuff that I've covered in this session is actually in this book called JavaScript Design Patterns. It's by O'Reilly, but you don't actually have to go buy this book. If you go to Adi Osmani, who's the author, he has the entire text of this book on his GitHub account. So you can literally just go clone the Git repo, and the entire book is online there. Okay? And so we're going to skip over the part where we go into some detail about talking about this kind of stuff in Backbone. But a couple of other things I want to mention is we've been talking about patterns, and we've been looking at a couple of different things. If you're not familiar with this website, this is an absolute must, especially if you're exploring JavaScript and you're looking at design patterns and trying to raise your JavaScript foo. The To-Do MVC website is an excellent resource. What they essentially have done is they've taken Backbone and Angular and Ember and Soma.js. I haven't even heard a lot of these before, right? So here's this example in Kendo UI. It's basically a to-do list application, right? Finish session, drink beer, sleep, whatever, right? And you can see if we go and work with this, this is implementing Kendo UI. Right, you can see that we have essentially the exact same to-do list application written with all of these different frameworks. So, if you're like me and you're bored on a Saturday night, you open a beer, you go pull up the latest Git repository and you start reading through the code, right? This is a great way to go and learn how two things, how these frameworks are supposed to be consumed, because these are what we would consider to be reference examples written in these frameworks. And the other thing is you get a feel for how a framework is put together. You can kind of look through the code, and obviously all the code is here. So if we go into their Git repo, you can drill down into the specific examples. And if we go look at the Angular example, right, you can see you have all the source code that you need to be able to understand how they built this to-do list application. In this case, we're looking specifically at Angular, but you can see a reference implementation of this application and all of the different frameworks. Now, let me go back. So one more thing I want to mention quickly is what's also useful in terms of, again, understanding the frameworks, understanding JavaScript, understanding design patterns and how they're applied by these frameworks is, I was talking with somebody about an hour ago about GWT and if anyone still uses it. I don't honestly. Does anyone still use GWT? All right, so a few unlucky people here. Great. I'm just kidding. So So the comment was, we're not kidding, yeah. So, but you can actually go and look at how they implement the same to-do list in GWT. But if we go all the way to the bottom, they've actually implemented the same thing just using plain jQuery and plain JavaScript. So it's kind of neat to start from the vanilla JavaScript, go to jQuery, and then go up to something like a Backbone or Angular and see how kind of the way that we approach building single-page web applications has evolved over the last 3 or 4 years. And literally, this stuff has all happened within the last 3 or 4 years, right? This is all new stuff. Most of these frameworks didn't exist 3 years ago. Obviously, jQuery is not a framework, but it's been around for a while. The other thing in terms of looking far into the future is there's this concept or new architecture for building single-page web applications called isomorphic applications. And they have a couple examples of isomorphic applications here with Meteor.js and Darby. But the reason why these are interesting is because this is what a lot of people in the community consider to be like the next generation beyond what we're currently using. Isomorphic applications are essentially apps where code runs both on the client and the server and can be moved around from both, and lots of little things in there, but it's the whole premise around them is wrap super fast development and having portable code between the client and the server. Obviously your server in this case will need to be Node.js, something that runs JavaScript, but don't let that scare you away from at least exploring these things. Okay, and with that I think we're near the end of time. I'm sure everyone is itching to go home or go to the bar or whatever. So I'll wrap it up a little bit early. Do we normally do questions here, or is there in the conference? Yeah, go ahead. Ah, yes. Okay. Okay. So the comment is when I was working through some of these code examples, I actually didn't use the this keyword very much, right? And the this keyword is essentially the context of an instantiated object in JavaScript. And the comment is it so broken that you don't use the this keyword? That's not completely true. There are certain cases where we use this sometimes, right? But the problem is just trying to explain the this keyword and all the nuances around it can take up an entire 60-minute session. So I try to avoid doing those confusing things. Like, we could spend 60 minutes just talking about doing comparisons in JavaScript, right? So the comment is that that's a good reason not to use it. We don't purposely try not to use this, but we find that there are other ways which are kind of simpler to understand semantically as we're writing code. And you know what writing code is like. You write code today, and then 3 months later you look at it and you're like, what the hell did I write? I have no idea what this does, right? You can write code that looks like Perl in any language, right? So I apologize for people who like Perl, but I had to go to therapy after doing Perl for a year, so it's what it is, right? Yeah, so I'm sure there are other people who had the same thing. So yeah, we don't try to necessarily avoid using it, but we find there are simpler ways to attack the same problem, like with the mix-ins and some of the factories and stuff like that. So, but sometimes you do have to use it, right? Okay. More questions? Anybody else? Yes, sir. Go ahead. Ah, this is a new question. So the question is which one of these JavaScript frameworks would you not recommend? This isn't being recorded, is it? I'm just kidding. All right, so, okay, so that's an excellent question. Honestly, I haven't used all of these or looked at all these in detail. I've looked at Ember.js, Angular, Backbone, several others on here, CanJS. Reactive is one of the frameworks I actually really like a lot, even though we don't use it. We tend to use Kendo UI because we think it's super fast, and we like the widget-driven approach as opposed to the template-driven approach, at least for the stuff that we're building. But in terms of what to avoid, that's a good question. I'm not sure exactly how I can answer that. I can tell you some of the ones I don't like on this list. I don't think Ember.js is a great framework for doing certain kinds of applications. It's very heavy. And there's a lot of magic in the framework, and I try to avoid using magic as much as possible because I like to keep my sanity. I like to understand how everything works from top to bottom within a single-page web app. And the other one is I'm not really sold on Kujo.js. Kujo.js is just it's a framework from the folks at SpringSource, VMware. what are they called now? Pivotal or something, right? Go Pivotal, right? But essentially, it's from the Spring Source people, and it got a bunch of cool stuff. It for example, has a Spring framework like dependency injection framework in JavaScript and a lot of other things. But I just don't think you need a library to add that, right? We built a dependency injection thing in a few lines of code here. So I like to go more towards simplicity and try not to use something. That's why I like Ember.js and Cujo.js. They're very big and they're very complex. And it's already difficult enough building a large JavaScript application without adding a massive framework that's very complex on top. So that's about the best answer you're going to get out of me today. So, all right. More questions? All right. Well, thank you for coming. I hope you enjoy the rest of the show.